Hello everyone, my name is Amrinder Pal Singh. Today I am going to present a video lecture on the working of a coal handling plant. CHP stands for coal handling plant, a plant which handles the coal from its receipt to transporting it to a boiler and store in bunkers. It is a process of raw coal to make it suitable for boiler operation. With their extent of work, we can say that receipt of coal from coal mines, weighing of coal, crushing it to required size, and transferring the quality of coal to various coal mill bunkers. This is the jointly responsibility of and duty of the coal handling plant and their staff members. In introduction, coal handling plant is to supply the quanta of processed coal to bunkers of coal mills for boilers operation and to stack the coal to a storage area. Coal is a hard black or dark brown sedimentary rock formed by the decomposition of plant materials widely used as fuel. A piece of coal called coal lumps. Mostly in India, the grade of E and F coal is used. There is a five-way of transportation of coal, but mostly railway transportation is used. It is cheap and safe. This chart shows the rating, or you can say grading of coal, their quality. This table shows three columns with their grade, with their calorific value, that is CV, and percentage of ash plus moisture content present in the coal. Look at the grade 1 quality of coal is grade A. They're having maximum calorific values greater than 6200 with their only ash contents and moisture contents is around 20%. The lowest quality of grade is F, and their percentage of ash and moisture contents is around 50%, and the calorific value is 2401 to 3360. In India, mostly E and F grade coals is used, and there is a grading of D quality coal. Its blending is done to get average D. It's a mixture of two qualities of coal. This is the bunkering cycle process. These are the two vibrating feeders where coal is passed through the surge hopper and transport to the bunkers with the help of conveyor belts. The size of coal lump is about 600 mm. In their first step of their crushing process, it becomes 300 mm. It's their coal lump size is 600 mm and they're reduced to 50% around 300 mm on their first stage. Then again it is double rotary crush, pass through double rotary crush and become their size is 80 mm, and again it crush to the crusher to decrease their size around their less than 20 mm. Then this coal is fed to the coal mill for pulverization. Even when the bunker is full, the coal is used for stacking or storage of coal in a coal storage area. This is the contents present in the coal. Around 43% is carbon contents and 3% of hydrogen contents. Nitrogen and sulfurs are less than 1%. This is the consumption table of coals in any thermal plant. If the generation is 120 megawatt, then per hour use of coal is around 80 metric tons. In the average of per hour, we calculate per day consumption of coal is around 2000 metric ton. Similarly, if there is a 4 generating sets, then the total requirement of coal is 8000 metric ton in a single day. Similarly, if the generation is around 210 megawatts, then coal consumed per hour is 120 metric ton, and in a single day it used 3000 metric ton. If the generating set is number there is 3, then the total requirement of coal is 9000 metric ton in a single day. This is the transportation system of the coal. The first is with on roadways. This is mostly used for a lower distance of thermal power plants from the coal mines. If their distance is around 100 to 150 kilometers, then this types mode of transportation is mostly used. In this roadway transportation, coal is carried in trucks, and truck contains around 8 to 10 metric ton coal per truck, and it requires more power and more time and manpower. Hence, it is not suitable for large power stations where coal requirement is more. And for high requirements, then mostly, preferably in India, the transportation of coal is on railways. It having the capacity of around one rack consists of 52 to 56 wagons, and each wagon contains 55 to 58 metric ton of coal. Wagon movements are controlled by battle chargers. Most popular transportation of coal is railway. These are the equipment used in coal handling plant. These 7 equipments. On next slide we will discuss each of them. First one is pull cord switch. A series of such switches are arranged in series at a 1 meter distance on the side of conveyor belt. The power supply to rotor of the conveyor belt is established only if all switches in series are connecting. Second equipment is vibrating feeder. The coal stored in a huge hub is collected on the belt through vibration created by the vibrating feeder. Third equipment is flap gates. These are used to channelize the route of coal through another belt. In case the former is broken or unhealthy, the flap gates open let the coal to pass. If closed, stop its movement. Next equipment is magnetic separator. These are used to separate the furious impurities from the coal. Fifth one is metal detector, which detect the presence of any furious and non-furious metal in the coal and sends a signal to a relay which close to seize the movement of belt until the metal is removed from it. It is a basically it is basically consist of transmitter and receiver. The working of metal detector is of small transistor which are installed in near to conveyor belt and working with the oscillation of 1500 hertz at 15 volt. The receiver receives this frequency signal. If there is any presence of metal in the coal, then this frequency is disturbed and tripping signal is sent to relay to stop the conveyor belt. 6 equipment which are used in coal handling plant is belt weighter. It is used to keep an account of the tension on the belt carrying coal, and it moves accordingly to release tension on the belt. Seventh one is reclaim hooper. Reclaim Reclamation is a process of taking coal from the dead storage for preparation or further feeding to reclaim hoopers. This is accomplished by belt conveyors. This is the conveyor system of any coal handling plant is conveyor belts, idlers, pulleys. With the help of these, we can transport the coal in between the plant. This is the diagram of a conveyor belt system. This is the side view. You can see it's a tail pulley and head pulley. In between there is a belt. This is the top view of the conveyor belt. Tail pulley, head pulley on conveyor belt is with the help of idlers. The crushing of coal in three stages. First is primary crusher. It crushes up to 600 mm size of the coal. Second is secondary crusher from 600 to 100 mm coal, and the final crusher is up to 25 mm size of the coal. This is the operating sequence of coal handling plant. This is the operating sequence of coal handling plant from where it's direct to bunker or direct to stack or stack to bunker. These are the problem faced in coal handling plant. First is their design problem. Second is their rainy season problem. This is the most important problem. In this season problem, there is chances of some added in moisture content in coals for their grade down their low quality, and other miscellaneous problems such as snapping of belts or ropes, derailment of coal wagons, oversized coal or muddy coals. Conclusion: in this way, we conclude that coal handling plant is the heart of any thermal power plant. Without coal handling plant, we cannot imagine any thermal power plant which generate electricity. In this way, coal handling plant is essential need of thermal power station. Thank you.